Okay, so first we have Nathan from Anchorage.
Hi there, testing. Hey everyone. So I'm Nathan. I'm the co-founder and CEO of Anchorage. We're digital asset custodian. I'm actually not here representing Anchorage, but another project that I and some industry participants have been working on. Basically around seeing if there are ways for the crypto community to have more collaboration, particularly on the security front, for a couple of reasons. Big reason being that a lot of the legislative and regulatory pressure that the crypto industry is coming under is because of various nation-state level attackers who are getting large amounts of access to crypto through bridge hacks, through DeFi hacks, and through other kinds of weaknesses that are a pragmatic reality of the current state of the crypto industry. And so part of the goal there is to see if there are ways that we can all work together better in order to improve security of the entire ecosystem, and in some ways to self-regulate. Self-regulation being a vastly superior alternative to being regulated, say, at the federal level, particularly when it comes to DeFi, layer ones, and all the other wonderful things that we want to build. So 3 initiatives that I want to talk about there. The first one is that Anchorage and several others launched this questionnaire called the RECT test. The idea behind the RECT test is it's a way for a DeFi protocol or an L1 or a bridge, any kind of independent piece of infrastructure, to assess their security posture, to see have they successfully achieved a good security posture. Just a basic hygiene test that can be applied to your organization. So that was the first kind of output of this working group that we put together. The second one is that we're going to start something called the Crypto ISAC. The idea behind the Crypto ISAC is similar to the other ISACs, if you're familiar with them. It's information sharing among regulated participants, say exchanges, custodians, banks, anybody looking to share threat intelligence information. Use that as a way to go forward. The third one that is going to be launching over time is a standardization of the auditing framework for digital asset projects, whether that be DeFi protocols, bridges, exchanges, custodians. How do we kind of across the board ensure that our security posture is getting better and that we are able to be audited against that? As you all know, almost every DeFi protocol, bridge, et cetera, goes through a security audit. Is there a way for us to standardize and customize that so it is well trusted by all industry participants? So we're going to take some time to put that together. We are going to launch that auditing group in collaboration with a number of the large exchanges and custodians and L1s, and we'll have that launching later this year. Interested in having people join us, and so if that sounds like something that your organization or your L1 would be interested in, please feel free to reach out to me. I can be reached at nathan@anchorage.com. Thanks for your time. Have a good day.
Okay, just introduce yourself.
All right, cool, 3 minutes. Hi, everybody. I'm Chris Lee, ex-Microsoft and the founder of Oak Network. These are our slides. So at Oak, our mission is to build the Stripe for Web3. Basically, an infrastructure that equips developers, app developers, with the tools to integrate the automation features into your products. Today, I'm very excited to show you the products developers have built with our technology. Imagine a stablecoin recurring payment web app that runs like clockwork. A yield boost auto restaking feature integrated into your wallet, your mobile wallet. An auto compounder for liquidity pool rewards, enhancing the functionality of your DEX. Our product's potential goes beyond these. Other examples like limit order on DEX or auto buy functionality on NFT markets. Furthermore, the ultimate goal is to offer a no-code tool, empowering user with the flexibility to build their own unique automation strategy like this one. To overcome the challenge of building automation, we have built a Polkadot parachain, which is a layer 1 blockchain that combines proof of stake with unique data structure and a private oracle. Behind the scenes, there are a few other technologies enabled our possibility, which are account abstraction, cross-chain messaging protocol, and modular blockchain. But why to build this automation on blockchain, right? Security is paramount. And that's why we choose to build this chain-level security with our network. Basically, within our network, there's no sudo wallet that has unchecked admin rights, and any change to the network need to go through the governance protocol, a DAO, ensuring decisions are made collectively. Our ambition don't stop here. We are actively exploring pathways to extend this automation functionality to other ecosystems like Ethereum. So if you like the concept of enhancing your product with automation feature, or you are interested in building with us, let's definitely connect.
Okay.
Thank you. I'm Chris.
Yeah. Thank you. Okay, we have our next speaker. Just introduce yourself first.
And we go. Hi guys, my name is Vitaly. I'm one of co-founders of a company called ZKX. I don't have slides today. What I will be talking about in a very short term is what we do, but mainly why I'm here on this stage. If you want to see details, talk about it, I'll be at the Starknet Summit this Thursday. In general, ZKX is the DeFi platform for perpetual swaps on Starknet, on L2, but that's not why I'm here today. When we started developing ZKX 3 years ago, we realized that there are plenty of things you can do on-chain on L2. It's much cheaper, it's faster, but equally there are a few things that you cannot put in the normal constraints of a blockchain. You either don't want to load the blockchain, or it's prohibitively expensive, or it's just impossible because of the number of steps and limitations. Things when you want to do the forecasting of some price movements, when you have high volatility of the markets, when you want to have the big data model, you just can't put it on chain. So our solution to this was the development of a decentralized node network that sits on top of Starknet. What you can do with this network is you can initiate the request on chain, you can have a computation in the arbitrary format, arbitrary computation within the node network, and then you can have the consensus of the results of the computation and put it back on chain for the consumption on chain within the smart contracts. The key differentiator for us is we always wanted to build a system that is A, decentralized, and B, permissionless. And as you know, having something that has to be fast, but equally you have to have the results in the permissionless way, and the node network should provide some consensus within the computation. That's very challenging. The practical reason for us to build it was initially because we wanted to have a massive order book. Initially, the permissionless comes from the ability to have decentralized order book, but in a permissionless way. And that came to the situation where we built a system with the ability to run any arbitrary computation. So now the question, why I'm here today, why I'm talking about this. If you think that whatever you work on, your protocol, your product, your platform can benefit from having a high efficiency, high performance computation that can be proved with the case on chain. If you think that you've been limited with what you can do on chain in terms of the either mass data storage or computation or work with the data, please do and either come to me and talk to me or find us online. This is the node network is still in development, but we want to see more projects and more protocols coming to us, trying and see how it can benefit you. That's it. Thank you.
Thank you. Okay, yeah, just introduce yourself first.
Hi everyone, Jay Berg here. I'm the founder of SidePit. SidePit is the first ever fair electronic exchange. We solve, not only do we solve MEV and front running, we solve high frequency trading, co-location, and all manipulation. I want to talk about why MEV exists on blockchain and how a new approach to solving this problem. So let's take the original blockchain, Bitcoin. Alice sends money to Bob. At the same time, she sends money to Lisa. We have a double spend. It gets ghosted across the entire globe. Half the globe thinks it's Bob's money. Half the globe thinks it's Lisa's money. So what do? We choose a miner at random, and we say this miner, we centralize each block. We centralize around a single miner. We say you choose which way. By centralizing around the miner, we end up solving decentralized money. Now let's take exchange. We have everyone could join the exchange. It's a multi-party game. And what we want is the correct ordering of events. So we need some sort of trusted party, trusted mechanism to choose this order of events. It turns out choosing a random miner that could also be involved in the exchange is actually the worst possible solution for this problem. So the centralization that creates decentralized money actually breaks exchange. So what I want to, the way we approach this is a new blockchain abstraction. And instead of starting with, a protocol, we aim to solve the end utility itself, and that utility is exchange. And first off is you need price discovery, and the second thing you need is counterparty risk mitigation. So with these two ideas, what we use what's called rational design theory. And the way that works is you design mechanisms and you look at the result of the running system, and if the result of the running system ends with the utility of what you're looking for, and the way you design that is you try to find a Nash equilibrium amongst the potential adversaries together with the designer intent of the protocol, and if you could get that, you end up with what we have is a SidePit decentralized exchange. We're launching a seed round, and we're looking to build this, and hopefully by the next bull market, we'll be able to trade without being manipulated, whether it's the centralized manipulation of high frequency co-location or the decentralized front running. And the core crux of how we got here was not relying on the blockchain design pattern and using a new approach, which other people have come on it too, to reach an equilibrium at the end that results in the utility you're trying to build from the beginning. And that's what we did with SidePit. And thank you.
Thank you very much. Maybe, while you're getting set up, just introduce yourself quickly.
Yep. Hey. I'm Pascal Berang from NIMIC and the University of Birmingham. And just a second, there should be a slide coming soon. Okay, I can get started already because I won't take long. I won't talk about the project today. The reason I'm here is NIMIC is doing a trusted setup ceremony for ZKPs for the cycle of MNT4 and MNT6 curves with 753 bits. And we would like as many people to participate as possible, obviously. And the powers of tau that we'll generate obviously can be used by other projects. So it is a good cause to participate. We don't have a fixed date yet. We're currently in the preparations of it. We will use the same multi-party computation that Celo or Aleo, these two projects used. If you want to participate, if you're interested, send an email to zkp@nimic.com and we'll inform you once we know more details. We won't send you any spam, we won't send you anything else, just let us know. If you're curious about the protocol itself, you can go to the link there. We also opened up a bug bounty program for our ZKPs as of today. So there's a link to that one as well if you are interested in that. So we built our ZKPs with Arcworks. You can join the bug bounty program too. All of the links are also on the QR code, so you can scan the QR code and you can help us and participate in our trusted setup ceremony. That's all from me for today. Thank you very much.
Thank you.
Hello, I can get started. Okay, so I want to talk to you about some exciting research we just did, which is called superfinality for Ethereum. Okay, so the idea is we all know Ethereum is secure up to 33% fraction of the stake turning adversarial, right? Recently, we have seen though that more than 35% of the stake goes through a centralized service like Lido. And this has raised quite some concern in the community about, okay, what happens to the safety now? So let's say you are an exchange and a customer comes to you, wants to exchange 5,000 ETH, a big amount, for like USD in return. And so as an exchange, your question is, when is it safe to transfer the USD? And so you observe the transaction on the chain, and traditionally, you would use like finality that comes from the Ethereum's Casper protocol, which is if you consider the transaction finalized, then you know that this can't be double spent, this can't be reverted unless 33% of the stake is adversarial, right? But the question is now, can we have more safety than 33%? The answer is yes. Alice here, who runs the exchange, can implement locally some rule that we call superfinality. It's as simple as finality. You just look at blocks and votes and decide when something gets super finalized and then let go of your USD. And I think the cool aspect of this is Alice can implement it right away. There is no need to change anything in the Ethereum protocol. It's just a local computation that Alice needs to do, essentially. We have an ETH research post that we have posted. There are QR codes, so feel free to take photos while I'm on this slide. And then there is more theory research backing this work, which we have on an archive paper up there, including application to other protocols, right? And we have a prototype implementation of this already. As I mentioned, you can implement it right now without any changes to the Ethereum protocol. And so we have a prototype implementation, but this is a research work, and we are happy to have other people who have use cases for this to deploy this in their use cases. And if this is something of interest to you, come talk to us. We are happy to explain the rule, the details, implementation, and so on. Thank you.
Thank you. Thank you very much. Super exciting. All right.
Okay, who's ready for some real researcher alpha? I'm Matt. I'm founder and CEO of Blocknative, and we've been doing mempool data stuff for about 5 years. Mempools are awesome. Mempools are coming all over the roadmap. But mempools are ephemeral. What if there was like this historical data archive of like 5 billion mempool events that went back all the way to like November of 2019, covering like everything? So you as a researcher could do like amazing things about MEV and censorship resistance and the merge and new stuff coming up. And what if you had free access to it? So we at Blocknative have this data, but we have this tiny little data science team, and we can't extract value out of it anywhere near fast enough. And we think that this historical mempool data archive is really vital for all sorts of research questions, both past, present, and future. And we are in the process of open sourcing this data for general community research use. But we need some people to go hands-on early. And so if you go to our documentation site, which is right here, you can fill out a form, and there's all these fields. There's 27 fields times 5 billion rows, almost exactly 4 years of data. And all that we want people to do is to dive in and publish research and provide credit. If you're a commercial application, sure, we'll talk to you about that, but this is really for research purposes. Every time we've dipped into this data set, we've found incredible things. If you're familiar with Black Thursday, when MakerDAO was exploited for a whole bunch and the Hammerbot thing was revealed, this is what we used. As far as we know, it's the only example of this data set in existence. Oh, by the way, it's not just historic data, it's going forward, so every hour it gets updated with current mempool data. We have a global infrastructure that does it all. So really, this is just an opportunity for interested researchers who want to incorporate incorporate historical mempool data and do new stuff. New resource for everybody. Check it out, docs.blocknative.com, or I'm around. I'm Matt. Thank you, everybody. And that was 2 minutes and 15 seconds. Cheers, bye.
Thank you, Matt. Thank you, thank you. All right, we have our next speaker. Do you have slides coming up? Okay, perfect.
Hi, I'm Mitchell Dong with Solios Energy Tokens, and I'm going to be tokenizing oil and gas. Before I continue, would somebody take a picture of me? I'll come to you afterwards to pick up the airdrop because I have to prove to my wife that I'm out here working. Okay, so I used to be an oil and gas trader for some 25 years. I used to own and operate oil-fired and gas-fired power plants, solar, hydroelectric power plants. And I've been trading crypto for 9 years. And I noticed that you can't trade oil on Binance or Coinbase or any exchange. And I thought, wow, one, you're being deprived of being able to trade oil. So I thought, well, maybe I'll mint a token that is backed by physical barrels of oil to be followed by cubic feet of natural gas, to be followed by tokenizing uranium. I used to be a uranium trader for nuclear power plants, and somebody may want exposure to uranium because they believe in nuclear power as a clean future energy source. I'm also going to tokenize lithium to represent the growth of electric vehicles and batteries for solar and wind. And all of this exists and does very well in TradFi, and you may say, well, why add Web3 to us? Well, it's because I want to give traders, investors on all the crypto exchanges a crypto-native way of trading energy commodities. So it'll be a cryptocurrency backed by these energy commodities. It'll all be on the blockchain. So my partner is created a series or a system to do all oil trades of 20 top oil companies on the blockchain. So it'll all have a proof of assets, and it'll be traded on crypto exchanges so that crypto-native investors can trade oil and gas and all these energy commodities in a crypto-native form. It's just like, why do you want to buy T-bills in a crypto form when you could just buy T-bills, from your broker? Well, because crypto investors want it in a crypto-native form. I'm currently raising money for this, so I'd love to talk to any venture investors who are interested in investing, and I'm forming a team of people who are technology traders, operations, accountants to pull this off. You can find me. I'm the Chinese guy with white hair and a red jacket, so if you're interested, please come to me. I'm hanging out at the receptions, networking as much as possible. Thank you.
Thank you very much.
Hello, nice to meet you. I'm from South Korea. I would like to introduce one of the main areas which my company developed. In particular, the transaction speed is very fast in the world. I think, as far as I know, the world fastest so far. TPS record about 12,900, pretty sure by today.
Feature 1. Faster data processing and improved security, cubing. CubeChain features faster data processing, called cubing. A cube is created upon the generation of 24 blocks, save for special blocks, and cubes are connected to one another to process data, hence capable of simultaneous processing of large amounts of data. CubeChain ensures not only the remarkable improvement in data processing speed, but further enhancement of security. That's because when blocks and cubes are created, double hashing are processed in a completely different way. Feature 2. Easy data retrieval, indexing block. As a convenient functionality to ensure rapid data retrieval, the indexing block is a set of data on the heights of blocks upon which address-specific transactions were made for e-wallets included in the entire transactions. A shortcoming of the existing blockchain is that searching for the transaction history of a specific wallet needs reference to all blocks, hence significantly time-consuming. CubeChain, however, allows for instant retrieval of transaction histories with the block height list of wallet addresses by simply looking into the indexing block. Feature 3. Rapid statistical processing. Statistics blocks. CubeChain has statistics blocks for rapid statistical processing with diverse applications. The existing blockchain requires searching the entire data to find out a specific piece of data, so it has difficulties in developing specific statistics. CubeChain's statistics blocks offer at-a-glance summaries of statistics on the entire blocks. By summing up highly utilizable statistical data using the statistics block, the users can print out well-summarized lists whenever needed. Feature 4. Safe Credit Transactions. Escrow Block. CubeChain has introduced a duplicate authorization system where escrow blocks are used to issue encrypted authorization keys for safe credit transactions. This ensures that cryptocurrency is not readily available in the recipient's wallet upon the completion of the transaction, offering a further layer of protection of transactions between parties.
Okay, thank you very much. If people want to see the rest of the CubeChain video, maybe reach out. Yeah. Okay.
Hi, I'm Prasanna Gautam. I'm a tech lead on protocols at Anchorage Digital, and I am representing Anchorage today. So some of you might already be familiar with Anchorage Digital, but for those who aren't, we were established, founded in 2017, and we are a regulated crypto platform that provides custody for institutions. And since 2021, we also have a federally chartered bank that we operate in the US, and that is regulated by OCC. We also have a Singapore entity for institutions that do not need to be regulated by the US regulations. And these are some of the investors. What I want to talk about is how we have built for trust and compliance. Our infrastructure, and the primary pillars I want to talk about is how we have built it for trust in hardware, software, and trust in process. And with this, we have already launched many chains as a day one partner and beyond with very new and novel interactions and blockchains. So the first thing is hardware. We really trust for the best root of trust in hardware. We want to make sure that we are always authenticating that there's a human on the other end of any transactions that are being approved. And all keys are always in hardware, no single points of failures. Same with software. You saw I'm actually using a Chromebook, and we've talked about how we actually use this as a way to reduce the attack surface in even how we write the code. We get our code pen tested and vetted by top tier security firms like Bishop Fox. And if you need regulatory clarity, if you operate in the US and you want the best regulation in the US, we have the coverage. But if you operate globally, and we also have equivalent security through our Singapore entity too. And these are a couple of chains that we've been launch partners or first institutional custodian for, and your chain could be next. These are some of our contact information, and you can also reach out to me directly on Telegram or Twitter or X, whatever you call it. Thank you.
Okay, thank you. So just very quickly, right now it's 12:30. We're going to continue with the lightning talks, but lunch is being served outside, so just want to make sure to give a heads up. We'll continue with the speaking in here, but if you want to grab lunch, it's outside.
Hey everyone, my name is Matt. I lead the Nervos Foundation, and I want to talk to you today about RISC-V and blockchain. So everyone is aware RISC-V is an instruction set, the language of the processor of a computer. And RISC-V is unique in that it's open source and it's not subject to license from any private company. So I work on CKB, which is a blockchain secured by proof of work and runs a RISC-V virtual machine. Now, because RISC-V is an instruction set as close as possible that you can get to the hardware of a computer, everything, or almost everything of this blockchain runs inside this VM. It's flexible, low level, and efficient. You can run CKB on pretty much anything, even this $100 laptop that I bought 7 years ago. Now, through the power of RISC-V, even the cryptography underlying transaction authorization is flexible and open to developers building on top. This is convenient. Many people hold CKB in Ethereum wallets, even though CKB itself is not an EVM chain. Now, recently, passkeys have been picking up steam across the broader industry, and Microsoft, Apple, and Google support this functionality at the operating system level, which allows private keys to be created inside secure enclaves of consumer hardware. And with this, there are no seed words, there's no risk of key loss, and there's a user experience of onboarding that only takes a few seconds. And with RISC-V on CKB, it's straightforward to implement support for passkeys, as well as any other chain's wallets. Well, quantum-resistant cryptography has also been tested, and there's a ZKVM with an obscene name I don't want to repeat here that's also been tested successfully. Now, it's theoretically possible to create contracts using any programming language. Right now, contracts are being created with C, Rust, and Lua. Now, CKB has been live for almost 4 years, and one of the magic things about RISC-V comes in here in that because it's a hardware instruction set, it's robust and it's also absolute. Now, this is important because it provides a nice path to ossification, which is an essential component of decentralization, but it doesn't do so at the expense of flexibility. Now, there are a couple other nice features that I want to touch on. It's possible one day we could see RISC-V coprocessors, which would be commodified, dedicated hardware that would deliver unparalleled performance. But today, with RISC-V being virtualized on these nodes, we get a nice, simple way of calculating the cycle cost to execute the virtualized RISC-V. Now, if you'd like to learn more, Google CKB, check out the positioning paper. It is the most comprehensive resource on the vision of this network. If it's all interesting to you, we have a diverse global community, and I want to give a big shout out to all the members of the Nervos Nation spread across the world, and to thank you, Stanford, for hosting this wonderful conference.
Thank you very
and thank
much.
you all for taking the time.
You're good.
Hello, everyone. My name is Xunxin Fan, Head of Research at LTEX. Happy to talk about deeping. If you've never heard about this term, deeping actually refers to the decentralized physical infrastructure networks. It's an emerging research area in the Web3 and IoT. So essentially, deeping leverages the blockchain, IoT, and token economics to incentivize the communities to build physical infrastructure networks for a certain purpose. Basically, they will enable the machine economy from the ground up. So deeping has a lot of potential applications. Basically, they can inject new blood or bring the new digital asset from the real world to Web3. While the deeping has a lot of applications, building such decentralized networks turn out to be challenging. You need to handle the device on the one side to interact with the real world, and to manage the device and the relationship with the device owner. Meanwhile, you need to use layer 2 infrastructure to perform certain execution, to process the data you collected, also maybe to do some zero-knowledge proof, to bring that insight to the Web3 in a trustworthy manner. Meanwhile, you need a well-designed token economics to incentivize the community to deploy those real-world hardware for a certain purpose, also to collect a different type of insight from the real world. Yeah, actually, there is a full scope of research questions to be addressed for entire deeping world. To facilitate the further research, we are actually organizing the first deeping workshop which is co-located with the IEEE World Forum on Internet of Things. If you are interested in this topic, you can scan the QR code to get more information. Yeah. Thank you.
Thank you very much. Just quickly introduce yourself. Yeah.
Hi, good morning or good afternoon and greetings. My name is Subra. I'm at Stanford in Cyber Knowledge, and this is going to be a short talk. I wanted to share with you some projects that we're doing with the overarching goal of improving trust in the digital ecosystem. And these intersect ideas that are both in Web 3, Web 5, decentralized key management, next generation digital identity, and Gen AI and privacy. So if you're interested in any of these topics, then I'd love for you to try and reach out. I can be contacted at PSUBRA, that's psubra at IEEE.org, and I look forward to connecting with some of you. Thanks very much.
Thank you. Thank you very much.
Sure.
Yeah. Very short.
Hello. I'm Panos from Visa Research, digital currencies team. So in Visa Research, we are working on several problems like how blockchain technologies can be applied in the digital assets world and improve commerce, cross-border payments, etc. So one aspect we are looking at is the ways of tokenizing on blockchains, for example, to adhering global standards to facilitate maybe interbank transfers or cross-border payments, etc. So all this have to be real-time, so much like the same experience when you do like a swipe with your credit card. We also want to have on-chain and off-chain programmability. We are also looking at privacy-enhancing technologies like MPC, federated learning, and how these technologies can be used as privacy-enhancing technologies within the scope of CBDCs to help detect anomalies like fraud or financial crime. I invite you to read our recent white paper about this, and also we have participated in the PETS Challenge hosted by this year by the NSF and NIST. So we have more exciting research projects in Visa Research with respect to privacy, auditability, compliance, custody, consensus, etc. If you want to learn more, if you are a PhD student who is interested in working with us over the summer as a summer intern, please reach out to me after any time in this conference, or feel free to find any member of our team who is here. Okay, that's all. Thanks.
Thank you. Thank you very much. Okay.
Okay, hello everyone. I'm Giulia Scaffino from the Technical University of Vienna, and I'm going to present you Glimpse, a bridge solution which is the result of a joint work with Luca Saumeier, Zeta Varichiotti, and Matteo Maffei. Glimpse is the first trustless bridge for proof-of-work blockchains, which only requires to relay and store on the destination blockchain a constant amount of data coming from the source blockchain. This is possible by using a new Superlight client solution which works on demand and, let me stress, works with constant size storage. This is an important improvement over state-of-the-art solutions, Superlight client solutions, such as NipoPOS and Fly Client, which achieve a logarithmic complexity at best. Our bridge solution is not only compatible with the second-generation blockchains, so it's not only deployable on those chains featuring quasi-Turing complete scripting capabilities, but can also be deployed, for instance, on chains with a Bitcoin-like programming language. We have analyzed Gleam security both in the UC framework as well as in the economic rational model. We have studied the security of Gleams, in particular when it comes to proof forgery attacks and censorship attacks. And we show in our paper, you can check it out at the QR code, how you can use our bridge solution in order to encode some cool applications also in the DeFi domain, such as cross-chain lending protocols, proof of burns, wrap and wrap of tokens, and many more. I encourage you to check out the paper, and if you want to know more, please feel free to approach me anytime in these days. Thanks.
Thank you. Thank you very much, Julian.
Okay. Hey, everyone. So I come from the University of Edinburgh, and I just want to be very brief to talk to you about a project we have. So the idea is to measure decentralization, or the levels of decentralization of existing blockchain systems. So far we've revealed our framework where we distill blockchain systems across 8, I think, layers. And the idea is to measure the level of decentralization in each layer and then combine them into a single index, which will rank blockchain systems according to how decentralized they are. And there is a lot of research to do there in terms of measurements, analysis, finding the correct metrics that give you enough information about decentralization. So if you're interested in these kinds of measurements, if you want to collaborate in any way, please reach out and you can find all the information on the website. And I should also say we've already released our framework and our first tool which measures decentralization on the consensus layer of, I think, 6 or 7 blockchains. Thank you.
Thank you. Okay.
Hello. Hi, I'm the co-founder of ZKM. So we're building a ZKVM for roll-up-centric Ethereum ecosystem. So our approach is actually targeting the MIPS instruction set. So why MIPS instead of like RISC-V as some other projects do? Because we're targeting Ethereum. So the verifier is actually a smart contract on L1. So this is very efficient because MIPS instruction set is very stable. We do this because Ethereum is at the end of struggle of scalability with Dan's talk about the erasure coding-based data availability. We're almost going to have like a very vibrant ecosystem that with almost unlimited scalability. That a roll-up-centric Ethereum means like there will be thousands of dApps that will run their own roll-up. So to build a ZKVM for them means that you don't want them because many of these developers are they're Web3 developers. They came from a background of programming JavaScript, now like Solidity. So they're not very familiar with building circuits. Like requiring like them to be able to do like, for example, Verilog when they're actually only familiar with programming like web. So with this purpose, we think a small core of instruction is a best choice for building this ZKVM. So this will be powering a roll-up solution we call hybrid roll-up. And the purpose is to have people to not really, like developers not really to do like ZK circuits design. They just focus on doing development for their dApps. So this is to making Ethereum like a universal settlement layer to enable like thousands of dApp roll-up chains. Yeah, so that's what we do. ZKM.io. Just go there and you can find everything to follow. Thank you. My name is Ming, ZKM.io. Thank you.
Amazing. Thank you. Thank you very much. Come on.
Hey guys, Mike from Artala here. We are building a new layer 1 called Artella. So we just finished our pre-seed round fundraising of 6 million. And also we are incubated by Interchain Foundation. So it's a foundation of Cosmos. So we are building on top of Tendermint BFT and will enable IBC in the future. So the uniqueness of our layer 1 is that we are a dual VM layer 1. It's EVM plus WASM. So why we choose this dual VM is because that we believe that the onboarding of the next million user is first to onboarding the next million developers. And developers, they choose WASM. So we choose like two basically runtime, EVM plus WASM. At Artella, we define a new programmable extension model called Aspect. It will work together with smart contract. But developers can build smart contract as before in EVM runtime. We keep the data structure of Ethereum, but also we enable them to build additional logic in WASM, we call it Aspect, so that they can build such kind of module to work together with a smart contract. So during the transaction's life cycle, developer can add additional logic in WASM in different stage of the smart contract execution, like block init, transaction verification, pre-execution, post-execution, something like that. And this aspect are running in WASM runtime, so it can provide much more efficiency compared with EVM. And also it can provide more secure sandbox for the contracts because it's as a browser security. So like developers, as for example, I'm a developer, I can build my logic in smart contract in EVM just as before. And because we keep the EVM equivalence as Ethereum, and also they can build intern solver in Aspect so that they can build such kind of additional logic in WASM EVM and enable them to enjoy the native speed. And this will be a universal for all infrastructure to support like all the potential like DApps potentially in all like future settlement layer because we enable IBC. And so for example, a use case is that like Uniswap or like some similar DEX want to use kind of like hook design. They can enable it with our design because usually like AMM cannot achieve limit order, but with the hook design, it can. So that with our design, every DEX can enable this functionality.
Thank you very much.
Yeah, I will give a speech tomorrow afternoon, so if you are interested, welcome to see our information. Thank you.
All right, good afternoon, Stanford. So my name is Jay. I'm a co-founder of Say Labs. So Say is the fastest layer 1 for trading, and we went live 2 weeks ago with our mainnet launch. So I guess for today, I have a minute and a half to speak. So I guess what I want to talk about is how we've been able to achieve 390 millisecond time to finality consistently ever since the mainnet launch happened. So we got started building with Cosmos SDK and Tendermint Core initially. And from there, we got a vanilla chain built after a couple of months. And then we started profiling the entire stack to see what is inefficient. And what we noticed is that with Tendermint, you have around 6-second block times by default, but there's a ton of room for improvement around how you can further optimize the way the consensus works. So one of the biggest things that we started doing is we started looking at how block processing actually gets started. So there's a pre-vote step, pre-commit step, and then afterwards you have execution happening. So the approach that we took is that rather than having execution happening after the pre-commit step, it starts happening at the same time as a pre-vote step. So basically, you will be optimistically processing the block while consensus is happening. This was one of the many improvements that we made that helped substantially improve the time to finality to help make Say the fastest chain in existence. So if anyone's interested in jamming more on layer 1 design, on consensus design, feel free to hit me up after this talk and also follow Say Network on Twitter as well. Thanks, everyone.
Thank you. Okay. Just pause the clock for a moment. Okay. Great. Okay, you can start the clock.
All right, hello. My name is Tingu. I'm from UC Santa Barbara. Today I want to quickly share with you a research project with NEAR. This is when we deal with Uniswap version 3 data. So our motivation is very easy, that we need to analyze these version 3 data, and we only have, let's say, transaction data set, but without the liquidity positions. So as economists, we asked ourselves, like, how is it worth it if we want to spend the time to energy to do it? The cost will be you have to track liquidity position for every pool at every given moment a block, and you have to analyze the data with more complex pricing rules. But the benefit is it really worth it? Is the increased accuracy worth it? I'm going to skip a lot of the math. We're not going to talk about it, but this is the results. So we found most of the transactions, almost like all the transactions actually, is within a really small deviation if you just use the simpler version 2 method to analyze version 3 data. If we actually look at top 50 pools, those are like consist of 60% of all the transaction on Uniswap. Even with, if we consider like the super small deviation of 0.0001% of deviation when you actually use version 2 versus version 3 model, you got 85% accuracy. You got 99% accuracy within 0.1%. So just to quickly conclude that using version 2 models to analyze Uniswap version 3 data actually presents distinct advantage in terms of both simplicity and accuracy. And here's a QR code to the paper. It's on SSRN, and we provide more details on how exactly we do it and how do we compare the two models. Thank you.
Okay, thank you. Thank you very much. Oh, perfect. Okay, go ahead.
Yeah, so me and Kite are organizing a very nice, I will talk in a minute. I might be getting to no, it's not. Here, go ahead.
Do we have slides?
Yeah, so we are organizing a seminar that it's mainly focused on economics and DeFi and blockchain, so less technical. We want to actually to make it be easy for everyone to understand the concepts about blockchain and DeFi. It's mainly focused for grad students because we believe that this is the new generation of researchers. You have here a very cool schedule. We have almost every week a talk. It's online. Everyone can attend. It's include the recording of past seminars. We were sponsored by Uniswap last year, hopefully maybe like next year. And we invite everyone to attend our seminar. And if you want to speak, feel free to contact me or Kite. And thank you so much.
Thank you. Okay.
Hello, everybody. I am Peer Zero. 10 failed startups in 10 years, but who's counting, right? I'm looking for brave co-founders because this time is different. I'd like to talk about unifying the 2%, which is us, the decentralized world, with the 98%, which is the rest of the world. So I want to unify in principle, the left and right, north and south, yin and yang, right? You get the picture. To a unity consensus. I call it the next generation consensus. The purpose is to onboard the rest of the world in the shortest amount of time. That's the only purpose. And we got to do this en masse, no more one-off. So the strategy is to go to their services. We're going to onboard their services. And we do this by taking the Web3 technology and wrap it in Web2 trustness, regulations, safety, and security. So actually, the bigger strategy is to onboard the Web2 en masse and all at once. There's no difference between Web 2 and Web 3. It's just technology. There's nothing to really separate us. So the idea is to the unification and unify the consensus. So right now, we're in the 4th industrial cycle. Blockchain was invented to dematerialize centralized processes. And the AI is here to partner with the blockchain. Thank you.
Thank you very much.
So thank you to Stanford Blockchain for this opportunity to present. I'm the founder of a new startup company called TV Feeder. My name is Jason Gilbert, and this is the new smart TV system. So you can have all your apps, streaming services, websites, video games computers, on your phone, tablet, virtual reality. It's got the buttons so you can do like sports, movies, music. And the way it's related to the blockchain is because this is the future of the internet. The whole internet's going to be decentralized. We're talking about the big tech companies, Google, Amazon, Microsoft, Facebook, Netflix, they own all the data centers. So what we need to do is we need to have decentralized data centers with all the networking infrastructure. We'll be all our own TV channels, all our own servers, GPUs. The GPUs can power all the AI. And so this is like the new smart TV system here. I'm the founder. I'm looking for co-founders and investors. And here's how you can like program all your favorite channels, favorite apps, favorite websites. Just like the new operating system for any screen. Here I'm showing it on the tablet, works on your phone as the new remote control. So you can cast it to the TV or watch it on virtual reality. You can have all your information windows. You can have news and sports and websites. And you click here on your virtual reality, click here on your virtual reality. So like I said, what I really want to focus on is decentralizing the internet and the data centers and really give power to the content creators, NFT for artists, musicians, DJs, comedians. They can live stream their content. They can go direct to consumer, peer to peer. So we don't need these big record companies, these big tech companies, these big media companies controlling all the middlemen resources. So really we can decentralize the whole entertainment and media and technology and networking infrastructure. Thank you.
Thank you very much. Okay, we have one last lightning talk, and then I think the next session will be starting.
Hey Stanford, my name is Ray. I'm the founder of Zeta. We are a Web3 backend service for online games. What we do is we bring games from Web 2 to Web 3 without really changing the core gamer experience. What it means, like if a user in Web 2 is still playing a Candy Crush or a Temple Run, they continue to play the same way. But what happens is every transaction, every events, every assets that is used in the game is actually on Web 3. So we do every of those things inside, underneath the hood or in the back end. Now that's how we are starting the journey. We started like 6 months back. We released the product out, a beta in 3 months. Right now we have got one game which is live. One other game is getting integration done and 3 others in the pipeline. This is the start of our journey though. It is not the end of what the goal is. Our goal is to build a decentralized or a trustless gaming ecosystem. How we do that is we send every game event that is getting played by every user, Web 2 or Web 3 in the games, to the chain. We commit all these transactions in bulks or in batches when the sessions are getting played, not in real time. We group it by session and send it to the chain or a decentralized public database, which is accessible by the community, where they can run. It brings in 100% transparency on one side, and on the other side, what we get is people can audit it, and this will lead to building a decentralized or a trustless gaming ecosystem. I believe this is something we need to have to ensure that each and every game we save the tenets of decentralization in place, but at the same time we might be a Web 2.5, but on everything on chain. Thank you very much for listening to me.
Okay, thank you. Thanks to all our Lightning Talk speakers. I believe the next session may be starting soon, but in the meanwhile, if you didn't get lunch, hopefully there's some lunch left.